Final project, predictive modeling for diabetes using SQL, presented by Katashia WIlliams. This presentation was prepared for HAP671 at George Mason University, taught by Dr. Farrokh Alemi and Dr. Timothy Coffin. According to the American Medical Association, about 1 in 3 adults, or 84 million adults, has prediabetes, while 90% of people are unaware they have this condition. An estimated 25% of type 2 diabetes patients in the United States are undiagnosed due to inadequate screening because it is prohibitive to administer laboratory tests to everyone. The, the electronic health could be used by healthcare professionals to identify patients with the risk of diabetes. According to a study published in the American Diabetes Association journal, Diabetes Care, the economic burden associated with diagnosed diabetes, undiagnosed diabetes, and prediabetes and gestational diabetes reached nearly $404 billion in 2017. Of that cost, $43.4 billion was associated with prediabetes. The data that we use is simulated data from a major healthcare institution in the United States. This slide shows the amount of patients that we have totally and the total amount of records we have for those unique patients. A simple definition for diabetes is a disease in which the body's ability to produce or respond to the hormone insulin is impaired, resulting in abnormal metabolism of carbohydrates and elevated levels of glucose in the blood and urine. According to the American Diabetes Association, diabetes mellitus is defined as a group of metabolic diseases characterized by hyperglycemia, resulting from defects in insulin secretion, insulin action, or both. Diabetes was examined using a comprehensive set of diagnoses that are associated with other health conditions. To assist with using technology to screen for prediabetes, these other health conditions could be a part of an order set. Age greater than 40 was added as one of the predictors for diabetes in the SQL coding. Some diseases are frequently associated with diabetes, such as complications with various organs, especially the eyes, kidneys, nerves, heart, and blood vessels. Disease affecting these organs are considered obvious predictors that always occur in diabetics. Here's an example of 3 of them. Code for 10 distinct rare diseases predicted from the data that occurred more than 29 times when executed. To show the association between diabetes and various ICD-9 diagnosis codes, the likelihood ratio was used. This slide shows SQL for the top 10 likelihood ratios for predicted diagnosis that are not obvious. Here, we are looking for overall risk of being diagnosed with diabetes, and the naive Bayes theorem was used to do that. This slide shows the calculations for the odds and probability of the diagnosis. Here is an example of a case with 5 diagnoses, corresponding likelihood ratio, and calculated odds of diabetes. The results of the naive Bayes calculation was joined with a repeated diagnosis table to get these results. By using a technique called cross-validation to train the model, I will acquire a training set of data and a validation set of data from the data model. By using 80% of the data for training and 20% for validation, here is the slide with the SQL code. This slide shows the SQL code to calculate the sensitivity and specificity to graph a receiver operator curve. This will give us the predicted accuracy of our model. What have we learned? As a conclusion, we have learned that predictive modeling is one of the best ways to diagnose for certain diagnoses, especially diabetes. The cross-validation method in calculating the likelihood could identify unlikely connections between diabetes and other unknown diagnoses. EHRs will be the future of helping to decrease patients with unknown diagnoses of chronic diseases. Thank you for watching this presentation, and here are my references. Goodbye.